This video will explain just a couple things that we need to watch out for in the proofs in module 18. So these are the intermediate proofs from the book. And so these proofs are basically the same as what we've done in module 17, just a little bit more complicated. The main thing we need to watch out for is when we have mixed woofs, or when we have statements in our arguments that are mixed woofs or contain multiple quantifications. So the important thing is that to notice that the statement there exists an x, px, and qx is not the same as the statement there exists an x, px, and there exists an x, qx. So there exists an x, px, and qx, the statement on the left, that we can use the rule of existential quantifier out on. However, the statement on the right, there exists an x, px, and there exists an x, qx, we can't use the rule of existential out on, not immediately. First, we have to use the rule of ampersand out in order to take it apart, and then we can use the rule of existential out. And let me show you what would happen if we tried to do it using existential out. So suppose on line 1 we have the formula there exists an x, px, and there exists an x, qx. So suppose we tried to use existential out on that. And so we said, okay, well, we'll get PA and QA by one existential out. This is wrong. And here's why. Let's see what happens if we do it right. So again, we have the formula there exists an x, px, and there exists an x, qx. And so we take that apart using ampersand out. But then when we go to instantiate it, well, the first one, line 2, sure, we can use A on that. So we can say PA by 2 existential out. But then when we want to instantiate the QX, we can't use A because we've already used that. So we have to use a different letter. So we'll use B, QB, on 3 existential out. So you can see how thinking that we could just do existential out on the first, on line 1 just right away and get PA and QA, well, that's not even a thing that we can get from these from that line. We can't derive both PA and QA. Just can't be done because of the restrictions. And even if those restrictions don't hold up in quite the same way with conditionals, so if we had the statement for all x, if px, then for all x, qx, still, we're not going to be able to just go, aha, PA, arrow, QA from that. No. We need to take it apart using the rule of arrow out, and then we can go ahead and do things with it. So just watch out for that. Watch out for what the major operators are, and make sure that you're using rules that are appropriate for that operator on the formula. So let's do another proof. Let's do a proof that sort of illustrates that. Okay, and also another point is that you can only use existential in to derive a quantified formula. So if you can't say, aha, I have the formula PA and QA, so I can just go ahead and get there exists an x px, and there exists an x qx. That's not legal. You can get there from there, but you have to do it slow. You have to do it in a couple steps. So you could say, all right, I can get PA, and I can get QA, and then I can do existential quantifier in on each of those lines. And then I can put them together. By 4, 5, ampersand in. So you got to do it the right way. Okay, so now let's look at a proof. So the proof we're going to look at has the premise for all x, fx, and for all x, gx. And from that we're going to derive the statement for all x, fx, and gx. So since we're deriving a universal formula, we need to start out by assuming the opposite of that. Okay. And then we're going to use the rule of QE to push that negation in. And then we're going to instantiate that formula first because it's an existential. So we'll get not FA and GA by 3 existential out. And then we can't say, aha, FA and GA by 1 universal out. Because this is not a universal formula, it's a conjunction. So we have to make sure we use the right rules on it. So instead we first have to break it apart using ampersand out. We get for all x, fx by 1 ampersand out. So that'll depend on 1. And then for all x, gx also by 1 ampersand out. And then we can instantiate it, because now the universal quantifier is the major operator. So we'll get FA by 5 universal out, and GA by 6 universal out. And then we can get FA and GA by 7, 8 ampersand in. Then we can put the FA and GA and its faults that FA and GA together. So that's 9 and 4 ampersand in. And then we would derive our conclusion. I've kind of run out of room again. But you can see that the next line would be for all x, fx, and gx by 2 through 10, dash out.